Hello students, welcome back to my channel. In this video, we will understand some important physical quantities like mass, weight, volume, density, and temperature along with their units and important conversions. So let's begin with mass and weight. Mass is the amount of matter present in the substance. For example, if we take a stone, its mass tells us how much matter is present inside it. Weight is different. Weight is the force with which gravity pulls an object towards Earth. This means mass remains constant, but weight can change from one place to another because gravity changes. Earth's gravity is 6 times stronger than the moon's gravity. Gravity on Earth is 9.8 meter per second square, whereas gravity on moon is 1.6 meter per second square. If a man has a mass of 60 kg, then what will be its weight on moon and earth? So weight on earth will be 60 kg into 9.8 meter per second square, that is 588 kilogram meter per second square or Newton. Whereas weight on moon will be 60 kg into 1.6 meter per second square, that is 98 kilogram meter per second square or Newton. So students, remember, mass is constant, weight depends on gravity. In laboratories, chemists use an analytical balance to measure mass accurately. Now let's briefly understand its different parts. This horizontal part is called the beam. It helps in balancing the two pans. These are the pans where the substance and standard weights are placed. At the center, we have the pointer and scale, which indicate whether the balance is balanced or not. This part is called the rider carrier. It helps in making very fine adjustments for the accurate measurement. The rider carrier knob is used to move the rider carefully along the beam. At the bottom, we have the pan release and beam release mechanisms, which protect the balance when it is not in use. And here the leveling screw is used to keep the balance perfectly horizontal. Since chemistry requires very accurate measurements, analytical balances are designed to measure even very small masses precisely. Now let's move to another important physical quantity called volume. Volume is the amount of space occupied by a substance. For example, water inside a bottle occupies some space. That occupied space is called volume. The SI unit of volume is cubic meter or meter cube. But in chemistry laboratories, smaller quantities are used, so we commonly use cubic centimeter, cubic decimeter, and liter. Now students, these conversions are very important for exams, so remember them carefully. 1 liter equals 1000 milliliter. Also 1 milliliter is equal to 1 cubic centimeter. And 1000 cubic centimeters equals 1 cubic decimeter. In laboratories, different instruments are used to measure volume. A graduated cylinder is used for measuring liquids. A pipette measures fixed small volumes accurately. A burette is commonly used in titration experiments. And a volumetric flask is used for preparing a fixed volume of solution. Now let's understand density. Density is the mass present per unit volume of a substance. Or we can say density equals mass divided by volume. If density is high, particles are packed more closely together. That is why some substances sink in water while others float. For example, stone sinks in water because its density is greater than water, whereas a block of wood floats in water. Since density is equal to mass divided by volume, its unit also depends on the units of mass and volume. In the SI system, mass is measured in kilogram and volume in cubic meter. Therefore, the SI unit of density is kilogram per cubic meter. In chemistry, another commonly used unit is gram per cubic centimeter. Now let's move to temperature. Temperature tells us how hot or cold a substance is. There are three common temperature scales: Celsius, Fahrenheit, and Kelvin. Kelvin is the SI unit of temperature. To convert degree Celsius into Kelvin, we use the formula Kelvin equals degree Celsius plus 273.15. For example, 25 degrees Celsius becomes 298.15 Kelvin. One interesting thing to remember is that negative temperatures are possible in Celsius scale but not in Kelvin scale. So today we studied mass and weight, volume, density, temperature, and important unit conversions. In the next video, we will solve practice questions and important conversions from this topic. If you found this video helpful, don't forget to subscribe to the channel. Keep learning and stay consistent.